Welcome to Assignment Overview 4.03, where we will cover trigonomic ratios, Part 2. We have learned right-angled trigonometry. We've learned SOHCAHTOA, sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent, and we have learned that theta is the referenced angle. Go ahead and take a snip of this screen so you have it for a reference if you do not have one already. We are looking at the ratios. We want to remember that tan is a ratio of opposite over adjacent. So when we're looking at angle Z, that's our theta. So we're going to look at the opposite over, let's see if I can get the 21 in there. There we go. Oh, maybe not. Okay. The opposite over the adjacent. So not the hypotenuse, but the one next to the hypotenuse. When we're looking at cosine, we need to remember that it is adjacent over hypotenuse. So here we're going to look at cosine C. Next to the C is 16, and the hypotenuse is 34. It's always the longest line. When we're looking at the sine ratio, we want opposite over hypotenuse. Here we're looking for sine C, so we want the opposite over the hypotenuse. The most effective way to calculate the values of sine, cosine, and tangent of an acute angle is to use a scientific or graphing calculator, like the one provided in Desmos. Remember, you can use desmoscalculator.com in order to find sine, cosine, and tangent. Make sure that it's set to degree mode and then press sine, cosine, or tangent in the calculator. The calculator will give a long decimal approximation. Most problems will involve rounding, since answers may vary due to the approximation. So let's use sine 25.3 like they did in the image. Here in this box, we can type in sine 25.3, and it will give us the ratio in a long decimal. Now let's find each of these trigonomic ratios using just the calculator. I've gone ahead and opened up the Desmos Scientific Calculator so that you can see how it works. Notice down here on the calculator, you have sine. You can click that button or you can type in SIN and then 12. This will give you the ratio for sine at 12 degrees. On our next one, we're looking for cosine 14. So we can click cosine or we can type in COS 14 and it will give us the trigonomic ratio for cosine 14. Here we're looking for cosine 52. All we have to do is click cosine 52 and it will give us the trigonomic ratio. When we're looking for tangent, we'll do exactly the same thing, except for we'll type in tan. In this case, our theta is 51. So we can type in tan 51, and it'll give us the ratio for the opposite over adjacent. Here's a triangle with a missing side. Notice here that we have theta, which is 27. We have the opposite side, which is 12, and we have the missing side, which is the adjacent. We can go ahead and substitute tan 27, and we can say that it's equal to 12 over x, which is opposite over adjacent. Now we can use this fraction to set up a cross multiplication to solve for x. So we're going to go ahead and put a 1 under x here. So I'm going to type this out so that we can visualize it. I'm going to say tan 27 divided by 1. That way I turn that into a fraction is all I'm doing, is equal to 12 divided by x. Now I'm going to cross multiply so that I get tan 27 times x is equal to 12 times 1. 12 times 1 is 12, and tan 27 times x is tan 27x. In order to solve this, I need to divide both sides by tan 27. When I do this, it's going to eliminate tan 27 from this side, and it's going to give me 12 divided by tan 27. Now, I'm going to find the value of x. Let's go ahead and use our calculator to figure this out. So 12 divided by tan 27, let me open this up so you can actually see this one here, is 23.55132607. Now, most of the time they're going to have you round that number. So let's go ahead and round it to 23.6 because it was 23.55. That is the value of this side right here. So this is going to be 23.6. And obviously that's approximate because I round it. Here we have a theta of 24. We notice that the opposite side when we draw an arrow is x, and we see that the adjacent is 12. So again, we're going to use tan because we have the opposite over the adjacent. So our theta is 24, and this is equal to x over 12, opposite over adjacent. Now we're going to cross multiply so that when we do, we get x is equal to tan 24 times 12. Notice that I got negative 3.07768. That doesn't seem right. So when I'm looking at my equation that I typed in here, I notice that I have tangent and then I have 24 times 12. Well, I need to make sure that tan 24 is separated from the 12 so that I do tan times 24 first and then I do times 12. This tells me that x is equal to 5.3427. Then I'm going to go ahead and round to the nearest hundredths place, which is going to be 5.34. Let's do one more just to say that we've got this. So here we have 21 as our theta. We notice that the opposite is x, and then we have the hypotenuse here. So we're not going to use tangent this time. Which one is opposite over hypotenuse? You have to have these memorized. SOHCAHTOA. So we know that it's going to be sine is equal to opposite over hypotenuse. So let's go ahead and fill in our blanks. We're going to say sine is 21. Opposite is x. That's the angle I'm trying to, or the measure I'm trying to find. And the hypotenuse is 22. Let's go ahead and cross multiply. So we're going to cross multiply sine 21. Make sure you put that in parentheses. Times 22 is equal to x times 1, which is just x. Notice that if I take that away, it's going to tell me that x is equal to 7.884. As always, let me know if you have any questions about this lesson or assignment.